Okay, welcome to another INB382 demonstration video. In this video, I'm just going to introduce you to the camera model inside of Unity, just at a user interface level and the concepts around manipulating the camera via its parameters. So as you can see here, I've just got my first project demo up and running. There's the oil can, also the oil drum with the normal mapping added, just as I showed you in the first lecture. Now the key thing to note here is that there is an entity called the camera as part of the hierarchy, the object hierarchy. So if I go back to the scene view where we edit things, so we can click on things and edit them, the camera appears as an editable object because it's an entity in the scene. It represents the agent or the controlling agent's viewpoint inside the environment. So not wishing to wax philosophical, we're just going to say that there's some being looking into the view and that you want to represent that to the person in order to facilitate your gameplay. So the task here then is just to understand, well, how can we manipulate this? Well, it's actually quite easy. I mean, we can use, if we wish, we can just move the camera around, and you'll see in the camera preview that if we were to run the game in that mode, via the camera, we will see that as we move the camera, the object moves around. Why? Because we obviously, if we move the camera down, the object moves up. If we move the camera up, the object moves down. And we can do that in all the dimensions. Funnily enough, because I have an orthographic camera, which I'll cover later in the theory, it doesn't change if I move the camera closer, but I'll cover that in a few seconds. But notice also that I have munged up the values. We can reset them. So this is a bit inexact, just using this here. So there's another interface to the camera over here. And it has actually a dialog box that we can manipulate. So I can just set its position back to its original, which was just a nice and easy, okay, it's going to be about 0, 0, negative 0.5, blah. And we're back to the original position of the camera. Note, I'm running the game. If I stop running the game, all these values disappear. So if you get mystified as to why some of your changes are not being saved, first lesson in Unity, if you're running things and you have a running game, changes by the dialogue will not be saved. This has been a cause of frustration to me on many occasions. But anyway, I move on. So what we're going to cover is just the basic parameters to a camera model in Unity that we'll then cover the theory of in the lecture later on. So going back here, let's go to the position dialog. As we can see here, we have a complete interface where we can select and set the position of the camera. I've already shown it to you using this, the axis arms on the camera entity, but here I can also set it actively as it's running. So if I set X to 1, the camera is moved across in the X-axis. It's translated itself by 1. And that means it's looking on the right-hand side. So the oil can, or the oil drum, moves to the left because you've moved the camera to the right. So I can set that back again. I can also move it, say, up by 1, which means I'm now looking over the top of the oil drum. And as I mentioned before, I can change this, so I could change this to -10. I've moved the camera back, but because it's an orthographic projection, we don't see any change in the distance. I've trucked the camera in and out, and it's not making any change. When is that going to happen? Well, that happens if you have a change to the projection. So if I make it a perspective projection, lo and behold, the camera view changes. We can see that the oil drum is now in the distance. So I can demonstrate now that if I change the values for Z, we start getting closer to the object. So this is the position of the camera, and this enables us to change the position of the viewer in the game. So that's all very good. So I'll just return that to orthographic. That's all very, actually no, I'll leave that as perspective. We can play around with that, and maybe I'll just shunt it back to about here. Okay, so that's Jim Dandy. Now what else can we do with this camera? Well, we can rotate it. So we can use the dialog again to specify in degrees the rotation around each of its own axes. So if I put a 15-degree rotation here, then it's rotating around the x-axis. That means the camera is now pointing downwards along the axis here. So I can just prove it. You can see how the camera is now pointing down, and as you can see in the view here, that the camera preview shows the object moving up. So I can reset that back again if I wish, and all of a sudden we have the camera pointing the object is back in the center. I can do that on the y-axis as well, so I can say maybe make it 15 in the y-axis. So if I move the view around now, we can see here that I've made the camera go off-axis with a rotation around the y-axis, and so the object has moved to the left. And finally, if I wish to, I can also rotate it a little around the z-axis. Now, because the camera is looking down the z-axis, you can see that effectively we've rotated the camera around the axis, and so the oil drum ends up rotating the opposite direction. So, what we can see here is that these variables control sort of standard positional terms inside the environment based upon the x, y, and z axis. So the idea here is that with rotation, the x-axis is often called the pitch. So going back again, if we put the 15 in there, then I've pitched it down by 15 degrees. So you hear that term. We can roll the camera by putting the values onto the z-axis, so that's called a camera roll. And then finally, in the y-axis, it's called a camera yaw. So those three terms are what you'll often hear referred to when dealing with the camera. In addition, you find with the position, changing the position of the camera x, y, z, the x position represents the dolly. So you dolly it to the left, or you dolly it to the right and dolly it to the left, as I'm doing there by changing the numbers. We can also zoom, so we can change the zoom on the values and get the effects that I showed before. And then we can change its elevation, so we can move it. I'll set that back to something approaching normal. Yep. And then I'll set the Y elevation to 1, and then we move up above the object. So they're the major values you're going to play with, because effectively in your game, most of the time, the camera parameters are set and you're moving the object around and rotating it and translating it in the world. But there are some other parameters you might want to play with. I've just shown you the perspective component. So if I change it from an orthographic to a perspective projection, we see that the nature of the scene changes and there are vanishing points introduced by the perspective. We get to that later in the theory. You can also, in the perspective projection, change the field of view, so an angle dictating how wide the camera frustum is. And as you can see, when I change the field of view, it has a similar effect to a zoom, in that the viewport is changing, and so the proportion of the object within that volume is changing in size. We can also set near and far clipping planes. So at the moment, I've got the clipping plane for near at about 0.3 in front of the camera. It's relative to the position of the camera. So if I change that to 10, that means that, as we can see in the scene here, the front clipping plane has moved forward to here. Note that the objects have disappeared in the camera here. So if I set the near clipping plane back to 0.3, the object reappears. We get to clipping later, but this just shows what is going to be visible in the scene at any time. So we can also have a far clipping plane. So if I set the far clipping plane to 0.5, same thing happens. The object in the scene, the oil drum, is no longer within the view of the camera, so it's clipped out. Okay, and I'll get to the theory about that later, but the sum point is you look on the camera view, you see nothing at that location. Only objects that are within the camera frustum, so if I move the object here, will start to appear. And I think I can only get that if I get the surface there. So you can see there, I've moved the scene around and all of a sudden the orc drum has appeared because it's inside the camera view. And so that's the near and far clipping plane. So I go back to the camera. Another one to note, actually no, I'll set the far clipping plane to some exorbitantly huge value. Again, I'll cover there's some theory about how big those planes should be because they control how precise your Z depth is for the Z buffer. But also we have the viewport rectangle. Now the viewport is a final transform applied to the projected points, which controls where it will appear on the scene. So I can change, say, the width of the viewport to 2, and you can see there that the camera view has changed because the window has changed. The object's not changed much in size, but its representation within the proportion of the entire scene has changed. So now if I change that camera back to 1, we get back to our original size viewport. So I can change it by 2 in height and width of 2, and as you can see there we have the same proportion view, but the viewport is now actually going to be double its size. So this is another way you can deform your scene, but also we can change where the viewport is in space. So we can also move it such that the viewport is now away from where the scene is. So I think if I give it a slight tweak, we're just moving it a little bit. So maybe if I go back to 0.3 and so forth and so on, we're finding that we're just moving the viewport's location in space. We'll get to more of that in a minute. So the viewport, the final transform for the objects, can be manipulated with this interface here. The rest of the stuff I'm going to get to later in the semester. Target textures, occlusion culling, rendering path, HDR, all those other things. They're more Unity concepts. These are the basic parameters that you have to manipulate your viewport and your camera. And I'll then show you the theory in the lecture about how this comes about from basic programming. Thank you very much.